Alright guys, we're going to talk about factoring again today, and we're going to be talking about a special case, when the difference of squares. Okay, and if you learn to recognize these guys, it could really help you out in the long run. Okay, so when we FOIL out looking at our first example, okay, there's a pattern when you have two numbers that can be that are the same, okay, 5 and 5, okay, one's a positive, one's a negative, okay. When you create this situation, like in our first example, x plus 5 and x minus 5, okay, if we FOIL those out, if you remember, okay, x times x is x squared, x times negative 5 is negative 5x, 5 times x is 5x, and 5 times negative 5 is negative 25, okay. When you start combining like terms, your negative 5x and your 5x will cancel, okay, creating x squared minus 25, okay. This is what we call a difference between perfect squares. Okay, if you'll notice, the middle terms canceled each other out when you multiply the binomials. This will always happen when the product is a difference of squares, okay. So if you can learn to recognize these, okay, this x squared minus 25, you can automatically know that whatever the square root of that second number, which is 5 in this case, okay, you're going to have an x plus 5 and x minus 5, okay, simple as that, okay. So just in our example down here, a squared minus b squared is the same as a plus b times a minus b. A times a is a squared. A times the negative b is a negative ab. B times a is ba. And b times negative b is a negative b squared. Okay. Again, a negative ab and ba cancel. Okay, leaving a squared minus b squared. Okay. Go ahead. Let's practice number 10 together. Okay. So looking at this, 4 is going to be my square of 16, and x is my square of x, so I'm just going to simply write x plus 4 and x minus 4. Okay? You can FOIL this out and check your answer, and you'll be able to prove that I'm right. That your middle terms do cancel, and leaving just x squared minus 16. Okay. Example number 11. Sometimes you have to actually pull out your greatest common factor first before you can factor the difference of squares. So if I pull out a 3 first in this problem, 3, that leaves x squared minus 9. Okay. Now inside my parentheses I have the difference of two squares, x plus 3 and x minus 3. Okay. Pretty simple. Example number 12. Here I'm going to pull out a negative 5x. Again, you still want that first term inside your parentheses to be positive, so I'm going to actually pull out the negative 5 here. Okay. And that will create the situation of my difference between two squares, because x squared, negative 5 from x squared is a positive x squared. Okay. And negative 5 out of 125, a positive 125, will leave a negative 25. Okay. Which we know from our example, x squared minus 25 is the difference of x plus 5. This factors into x plus 5 and x minus 5. Okay. So, and that's my final answer. Okay. Go ahead and try 13, 14, and 15 on your own. Pause the video and practice it, and then be ready to check your answers. Alright, here we go, guys. Here are the answers to 13, 14, and 15.